All right, is this thing on? Good. Good afternoon, everyone. I'm very happy to see so many people show up for my talk, so thanks for coming. I'm Bart de Smet. I'm actually a developer at Microsoft, where I've been working for the last 2.5 years on all sorts of data processing problems in a team called the Cloud Programmability Team. So you might already start thinking about the lots of possibilities we have there. And so I have two talks here today. One is specifically about reactive extensions, which is an event processing system based on LINQ. And I also have a talk about LINQ to everything, which is kind of a repeat that I've been doing of a talk for like many years, but sort of starting to add more and more things to it to sort of reveal the things we've been working on. And so the goal of this first talk here is to give you an overview of reactive extensions, what it is, why you should care about like doing event processing systems today. And more specifically, I want to learn you or teach you how to catch fish. Like, I don't want to serve you like, some plate of smoked salmon and caviar with lots of cooking recipes on how to create a beautiful dish. I just want to show you how to actually explore RX on your own. So the most important thing of this talk is to know the core concepts as opposed to getting a lot of little recipes that you can sort of blend together and not understand anything about what RX is really doing. So it's more about the understanding, and that's why it's actually labeled a level 400 talk. So let's actually get started by asking ourselves the question, why should we care about event processing? And in fact, this is solely based on an observation we made a couple of years ago when starting on this, incubation team that's doing a lot of cloud programming capabilities, is when you look at your application at the center of the world, the way you get your data has tremendously shifted towards a model by which data is being received by the application by means of event streams, as opposed to being with your application in the driver's seat where you actually actively ask for the data. So data is coming at you, and what you have to do is, of course, you have to react to that data. And so a couple of examples here are like, for example, stock tickers, things like RSS feeds, even though maybe the underlying mechanisms, the APIs and the HTTP protocol, are maybe not event-driven, but more like a pool-based mechanism. The way you want to program those things and the way you want to approach them is by means of event streams. We also have all of those sensors today. So your application that's running on a Windows Phone or a Windows 8 tablet, you have a lot of those sensors that actually come to your application and tell you that the device has been moved. You have to react to those kind of things as well. Social media is a very good example as well, the whole Twitter fire hose or Facebook of all of those things, and one of those social media things we acquired yesterday. And then, you also have server management scenarios, of course, where you don't want to sit and wait, or your application doesn't want to query the whole data center every few seconds to know whether one of the 5,000 machines might be down. You actually want to get an event when something goes to a red flag and something is actually not functional. So your application is the poor thing sitting in the middle with all those event streams coming in, and you need to coordinate that. And so what we do with reactive extensions is unify basically the representation of all those event streams using a common type, and then we build a stack on top of that that allows you to do query processing on top of event streams. And so that's basically the idea of RX. So the rest of this talk will actually be pivoted around this slide, which is the core architectural diagram of RX. There are 3 layers to it, and we'll talk about all 3 of them. At the very bottom, we have what I sort of tend to call our virtual machine, the place where things happen in the system. That's the concurrency layer where we do scheduling, where we make sure we can run timers, schedule things on dispatchers, those kind of things. Then we have the event stream abstractions in the middle with 2 core interfaces and a third one that's derived from that. And then on top of that, we build LINQ to events. And if you would actually look at this diagram as a pyramid upside down, the top thing would be the thing with the largest API surface. So that's the place where you have a lot of things to explore. And we don't have the time to talk about all of those capabilities there. But so we'll actually talk about the core concept so that you can go and explore that large API surface on your own as you walk out of this door. But so if you look at LINQ to events, the idea there is that you can write those event stream queries, which include typical LINQ constructs like filtering, projection, grouping, all of those kind of things, but also things that have to do with time. Say you have a large event stream with thousands of events a second and you can't actually afford to process all of them. Maybe you want to buffer them in groups of 5 seconds and do some aggregation on top of that. That's something unique to event processing capabilities. And so LINQ to events is really about all of those operators that allow you to compose over those observable sequences. So I already mentioned observable sequences now in passing. Let's drill into the middle section first, which are the core interfaces that you really need to understand completely before you start looking at all the other pieces here. And so I will focus on iObservable and iObserver, and the subject aspect will actually come out of that later on. So what's the core ID? When doing event processing, there are two parties. There's a sender and there's a receiver. That's always the case with, things that have to do with data typically. And so the observable sequence, the thing on the right here, in this case I'm taking a stock ticker, but you can substitute it for anything you've seen in the first slide, is basically the thing, the data source, that has the capability of giving you events. So it has the ability to raise events. We can wrap existing things like .NET events and sensor APIs and all of those capabilities that exist today in the BCL, and we'll talk about it separately. But the core idea is that we want to have a unified interface to rule them all. That's the basic idea. Then the second thing is observers. Observers are the guys that get the callbacks. Now you can compare this, for example, in the real world with subscribing something to a magazine. Like if you subscribe to a magazine, you basically have to give your callback address, your postal mail address on which you want to receive the magazines. So basically, as part of talking to that observable sequence, you have to give it an observer to call you back as soon as interesting data is available. And that's what we call the subscribe action. At which point, after you do the subscribe, you can sit back, relax, do other things. You don't sit and wait in front of your mailbox for the magazine to arrive. And so at some point, the magazine will be pushed into your mailbox. So that's the idea. Data gets pushed into your application by means of a callback to the observer. So how does this reflect itself into the interfaces? Well, there are two core interfaces that exist in the BCL today in MS CoreLib. In fact, if you do Windows Phone 7 today, it's actually in a different assembly called system.observable.dll, but it will move into MS CoreLib for Windows Phone 8. But so what those two interfaces actually are the representation of event streams. We have the iObservable with the subscribe action that takes in an observer. We've seen that before. And we have the observer, which has three callback channels: on next, on error, and on completed. And we'll talk about those in the next slide. Now, one thing to notice here is that what you get back from a subscription is an iDisposable. And that's the thing you use to unsubscribe in the future in case you want to stop receiving notifications. Like, it's kind of silly that we would actually have an unsubscribe method for various reasons, because unsubscribe would imply you hold on to the object you gave it in the first place. That's not compositional. That's very hard to get right internally. And it doesn't also reflect the real world. In the real world, to unsubscribe from a magazine, you get a little ticket that you can put back in the mail to say, I don't want to receive this any longer. Like, you get that together with your subscription. You don't want to hold your hand with your observer in the mailbox when you actually post a subscription, so that you can actually withdraw it at a later point in time. It's sort of fire and forget. You subscribe, and at the point you want to unsubscribe, you basically post the unsubscribe action by calling dispose on the handle. So that's the basic idea of the interface. Give it an observer, and you will get called back in the future any number of times. So what's the grammar of the observer? How can you get called back? We've seen three methods. How can they be called? So the way we represent that is by means of a so-called marble diagram. Marble diagram is a line in time that actually indicates a certain observable sequence and how a certain observer sees it. And the bullets that you see here are the on-next messages. They actually carry the payload containing the data. In this case, it's an iObservable of int. And at the very end, you can have a completion message to say this sequence has completed. The analogy with a publication company is maybe that they decided that at the end of the year, they no longer want to send any new editions of the particular magazine you subscribe to, because like nobody's buying it anymore. So you get an uncompleted that says, thanks for being a good customer. Unfortunately, we won't send anything anymore. So that's a successful termination of receiving events. You can also have an exceptional termination using an on-error. The important thing here is that the uncompleted and the on-error messages are terminal. So you can't have multiple of those guys actually happening. Now, you can also have infinite sequences. You can have sequences that have any number of on-next calls. You can have sequences that don't have any on-next calls whatsoever. Like, those are all valid sequences as well. One important thing to point out, they are sequences. This means you can't have re-entrancy in your callbacks. You can't have multiple on-next calls in flight at the same time. They need to be sequentialized, serialized, to still be a sequence. So that's an important thing that actually frees you from a lot of worries when writing RX code. This is the grammar in a slightly more formal form. Any number of all next messages, including 0 to infinity, followed by an optional error or completion message. This is very similar, by the way, to IEnumerable of t. In IEnumerable of t, when you call move next, you can get an element back, or you can get a false message back that says there is no further elements. That's the equivalent to uncompleted. You could also get stuck when doing a move next call. If the thing goes to a thread sleep infinite, it's basically an infinite sequence. It's just unfortunate you're blocked forever. In the world of Rx, you're not blocked at all. You just said call me back when something is available. They won't call you back if there's nothing, right? So you're not spending any CPU cycles whatsoever just sitting there and waiting. So now you might ask the right question, which is, can't we do this with .NET events? Why do I have to learn something new to do Rx? Well, here's a very innocent-looking piece of code using .NET events that does some stock exchange kind of manipulation. And there are 4 things that I identified in this slide that are wrong with this piece of code. First of all, events are not first-class objects. You can't pass them around. It's pretty hard for people that say, well, I want to do the UI visualization library of the stock exchange. Please give me the event that I need to subscribe to. How are you going to pass the thing to the constructor or set a property with the event? An event is not an object to begin with. Not unlike, for example, methods. Methods can be captured as delegates, so you can pass them around. But events don't have a first-class representation. Secondly, one of the problems with events is that you have to start dotting into those event args in a lot of cases just to find out that there is no useful data in the event. But in reality, there are sources of events. A mouse is a database. It's a database of points that are spread out in time. But you don't get to see that by looking at mouse move. You don't know that there will be a system drawing point inside. You have to sort of go and hunt for that one. Third, there is lack of composition, which really comes back to the first point of not being able to pass those objects around. Because you can't capture an event, you can't write a method that manipulates an event. You can't have something that says, I'm going to implement once and for all something that filters events based on some predicate function. Like, you can't do that because you can't capture them. So you end up in the la-la land of imperative code, where you double-click on the event and you start writing imperative code. Now, this might be good for an innocent-looking filter, but now say that you want to sample the sequence based on a timer. Now, all of a sudden, you have to write things to a field, make sure things are thread safe, start a timer next to it that samples the field. Maybe you don't want to get false positives if you're sampling, but there was nothing in the last interval, so you need to have a Boolean around as well. Now you have a timer and an event subscription. How are you going to cancel those two things? If you leave the timer running, but the event is no longer pumping, you will get false positives. The other way around, you will have bad things happening as well. So like the imperative la-la land is nice if you want to spend a lot of time. So I just want to dot things together. And finally, I've actually already mentioned that resource maintenance becomes pretty hard. You need to remember what you gave to a .NET event as the handler to be able to get rid of it. And now if you have multiple of those things sitting around, well, you need to remember a lot of things. If you merge 15 events, you need to know the 15 things you gave to the 15 events. So that doesn't quite compose. So what we do with observable sequences is we give it a first-class representation so you can pass it around. And the important thing in this slide is the 3 dots over there, like the little piece there that says, like, they're coming from somewhere. I don't care where I got them from, a field, a property, a method call, whatever. Like, I can pass those guys around. Because they're objects. It's an IObservable of t. It's a cup of tea. What does the cup contain? It contains tea, right? So you can clearly see what the data source is. It's an IObservable of point, an IObservable of quote. The off part is very important. And in fact, VB developers even see the off word in there. Next, we have composition. We can write those query operators on top of it. We can start writing things like where, something like .sample. It's as easy as writing a method that takes an observable and a time span, and you can do something like sampling. Third thing, or fourth thing, you don't have to remember the thing in the little comment over there at the right of the slide that you actually passed into the subscribe action. You don't need to remember what you passed in order to get rid of it. You get an iDisposable back, and if you have 15 sequences that you subscribe to, you get 15 disposables. How do you then maintain, a way to actually unsubscribe from all 15? You create an iDisposable around it. And actually, we have one. in Rx called composite disposable, which is really a list of iDisposables. So you can start composing the resource maintenance aspect as well. So that actually gives a lot of power, as we shall see in just a moment. Now, a pretty important aspect to point out here is that a lot of people are confused sometimes, like, does this make .NET events obsolete? Should I go through my code base and eradicate all of my .NET events and substitute them with observables? Well, the answer is likely not. And why is that? Well, they serve some different needs, but there are some pieces of overlap, of course. But with events, you're typically in a code-centric world where things like a button click, that's totally fine to do using like classic .NET event handlers. But like as soon as you want to start fishing at those event arcs, and as soon as you're dotting into those event arcs and go into a data-centric world, like maybe you should think twice. Maybe it's a better thing to actually go for observables. And I will show you that you can actually bridge between .NET events and observables pretty easily. Secondly, and that's all due to the first class or not first class aspect of those guys, the fact that observables are first class gives rich composition. You can write those query operators once and for all on top of them. They come at a slightly more cost because you have an object allocation, you have iDisposables sitting around. They're not finalizable, so there's no problem with that. But like there's a little bit additional cost, which typically far outweighs, all of the benefits. Well, the benefits outweigh the cost. That's what I mean here. And finally, with .NET events, and we'll talk about it by the end of the talk, you have a rigid execution model. You can't really look at the user intent. It's the CLR that's going to execute it. You can't intercept the intent of the user and send it to some other place unless you lift up the assembly and install it somewhere else. So we can also capture event queries using expression trees. So let's actually give a little demo here of, and now I'm confused which machine this is. I think it's machine 4. Looks like a black hole machine. Okay. All right. So the little sample I want to give you here, it's actually a passphrase, Never do passwords. Just type a little sentence, I'm going to walk with my dog in the park or something. Like, looks impressive, actually, and it works pretty well as well in terms of security. So what do I want to do here? I want to actually contrast .NET events and observable sequences just by having a little look at those two interfaces that we talked about before. And so in order to use Rx, well, you can actually get to the iObservable and iObserver interfaces just in the BCL. This is a .NET 4.5 project. You would see the same in .NET 4. You would see the same in Windows Phone. Like, if you go here, you see it's an MS core lib, blah, blah, blah. All of that stuff we've already seen in the slides. Now, what I want to do is draw the closest analogy to .NET events, so that we're all on the same page because everyone knows .NET events, right? So let's actually include Rx over here. If you install Rx, it's a download, it's an SDK. You will find it back in the extensions tab over here. If you're actually using Windows 8, which I will do later, there's a new concept called extension SDKs, which makes it easier even to include Rx. And starting with Rx 2.0, we actually have 4 assemblies. You might say that's quite a bit. The reason we've actually refactored Rx is to make sure we can support portable library. So in the future, you will be able to actually create Rx projects that target Windows Phone, Windows Phone 8, Windows 8, as well as .NET 4.5. And you don't have to recompile across those platforms. So I'm going to include those 4 assemblies. I will talk about the assemblies later. Alternatively, you could actually also include the NuGet package called Rx main, if the internet cooperates, that is. So I'm not going to wait for that, but Rx main is the thing you should look for. So what I want to do here is create a little example of an observable sequence by using something called a subject. Now, what's a subject? A subject is actually a sender and a receiver all in once. In fact, if I go to the subject object, you see it implements iSubject of t and iSubject of t, t, which implements by itself iObserver of a source and iObservable of a result. So it's something you can feed something into. It's something you can listen to as well. .NET events are exactly the same thing. Other than some protection that they have, you can't trace the event from the outside. You have to be inside the class. This is really like a pub/sub point, a place where you can publish, a place where you can subscribe. You shouldn't use this thing inside your query pipeline typically, and we'll talk about queries in just a moment. The place where you want to use subjects is on the edge of your reactive queries. Where data comes into your system, you actually have those endpoints that other people can talk to. And then data starts flowing in your query graph, essentially. So what can I do with a subject? I can do onNext on it. I can actually fire data into the subject by just saying subject onNext. But nobody's listening to this thing. So there's not really much going to happen. So what can I do? I can subscribe to the subject as well. So you have those two interfaces sitting here. I can do a subscribe over here. And as you can see, we also have extension methods to subscribe that don't take in an observer, but take in delegates. An onNext delegate, an on-error delegate, and an uncompleted delegate to make life a little easier. So I'm just going to do console write line here. So passing in an onNext handler that actually will say the first subscriber received X. And that's the F1 help. Next, I will do subject onNext of 43. So this guy will actually receive 43, so you should see that being printed at the console, if I would actually type 43 instead of 42, that is. And then I can also do like a second subscriber. So it's really a broadcast point because like now when I'm actually going to say 44 over here, both of those guys will actually see this thing coming through. Now what I've done as well is I've captured the disposables so I can get rid of the subscriptions as well at a later point in time. Typically you don't do that in the same method, of course, like it's asynchronous. You don't want to wait there for messages to happen or something. Like typically you stash the disposable way somewhere, and then maybe when the form closes or something, you actually call dispose on that. In a lot of cases you don't even care to call dispose because lots of those event streams are infinite. But so subject onNext of 45 will only reach D2, or actually subscriber 2, because subscriber 1 has disposed at this point in time. And so as I execute this thing, as you can see, we see 43 and 44, well, 43 being sent to 1, 44 being sent to 1 and 2, because it's being sent after the 2 subscriptions, and then you see 45 only being received by subscriber 2, because subscriber 1 already unsubscribed. So that's basically the idea of a subject. Here you've actually seen both the observer channel as well as the observable interface. Observable is this guy, observer is that guy. Didn't talk about on-error and uncompleted, completely the same. So let's actually switch back now to the slides and talk about querying, which is the next interesting thing. I think it's like that. Will it move? Oh yeah, beautiful. Good. So let's actually look at the top layer now. How can you write queries on top of those event streams? You already know the answer. It's just link. You just write link queries. You dot things together, and that's it. But maybe you should give a little bit more detail. So the sample I want to give you, and in fact it's changed a little bit for RxV2, so if you've seen this sample before, there are some subtle changes here that are actually for the better and make the code even nicer. The sample I want to give you is dictionary suggest, and I will actually do it on a Windows 8 Metro-style application, just to challenge myself a little bit here today. So the goal of this is actually to allow a user to type a word and then get all the words in the dictionary that start with the given term. So I want to compose an observable of string, which is my text box input, with a web service call, for which I will use async methods in C# 5.0. And finally, I want to get an observable of dictionary words back as soon as the web service completes the request. And then I want to bind them to the UI. Instead of actually starting to look at all the code here, let's actually switch back to the machine and start writing some code ourselves, and then we'll come back to the slide to talk about a couple of those points that you see over there. So this Windows 8 release preview. .NET 4.5, of course, comes with Windows 8. And RxV2.0 release candidate, which has been released last week, actually is compatible with the release preview. So I'm just using our release candidate of Rx here. I'm actually going to start from scratch here, just create a new project. I didn't anticipate it loading settings, but that's very welcome. And let's actually create a new project here, and I will go for a blank application called app3, which is a beautiful name. So, will actually look darn good in the Windows Store when I publish it later today. Everyone will want to have app3. So, what I want to do here is not stare at app.xaml, but actually go to the main page over here and start doing some superior UI skills exhibitions here, which will including a text box, or a text block as they call it over here. No, a text box, as well as a list box. So let's actually try this. Here's a text box. It's so beautiful. Whoa. Likely it worked. Xname equals text. I didn't anticipate that to happen. It's still release preview, so you know that that's bound to happen at some point. And let's also include a list box over here. And so let's actually make this a little bit bigger. And so the idea is when the user types in that text box, we'll actually go to the web service and give some data back, right? So let's make this slightly bigger and actually give this guy a name. And let's actually compile just to make sure that this little glitch in the designer didn't mess anything up. Okay, this looks beautiful. We'll leave the world of the designer now and go to the, real man's world, which is the code of world. The world of code, I mean. So let's go back here and actually start writing some code, by which I first of all want to look at the text box as an observable of string. How will I do that? Well, it already exposes the .NET event. We have a way to convert the .NET event into an observable. Why would you like to do that? Well, because then you're in the world of unicorns, where you can use Rx. So that's the first thing I want to do here, is convert text.textChanged, as you can see over here, into something meaningful. And so when you look at text-changed event handler, I'm just F12ing into this thing, text-changed event args, this is really kind of sarcastic. They derived from routed event args just to add nothing to it. Just to give you the impression that there is something meaningful in this guy, but it doesn't really contain the text that has changed. So that's the thing I'm interested in. It's the text that actually has changed. So let's actually wrap this guy by using something in Rx called observable from event pattern, which is a conversion between .NET events and observable sequences. So as you can see, when you actually use Metro-style apps and you install Rx, the Rx SDK, you will get an extension SDK, and it's as easy as just checking this checkbox to get all the dependencies. In fact, you don't even see the dependencies in Solution Explorer anymore. They're just hidden behind the scenes. So what I want to do now is I want to use this type called observable, which I can include like this. It lives in System Reactive Link. And I can do from event pattern to actually bridge with an existing event. And so what I'm going to supply here, I can use a number of overloads here. I will use a different overload when I do a Kinect demo later on. But so I'm actually just going to use the reflective overload this time. And I'm basically saying look on text for a text changed event. And I can also use a strongly typed one here, which I will do later. And this will actually become my input. Now, what's that input look like? This is an iObservable of something. It needs to be of something because we don't have a non-generic iObservable interface. So what does it look like if I do subscribe x goes to, what's x? What's the type of x? If you dot into it, oh, it contains event args and a sender. So you haven't gained anything yet other than the fact it's now an observable sequence. So now you can start doing interesting things with this guy. One of the interesting things you can do is the thing you typically do in a DBA world. You look at a database and you say, who designed this freaking schema of this database? I want to transform it into something else. How do you do that? The answer is select. You want to do a projection. So I want to project this stream of I don't freaking care what this is into a stream of strings. So I want to select I don't care about that underscore thing, like it's a sender and event args and it doesn't contain anything useful. Different story if you would use mouse moves, which contain the location. But so in this case, I just want to do txt.text. So what I have now is an iObservable of string. If I would hover over this, you see it's an iObservable where t is a system.string. So that's beautiful. Now I have a stream of strings. Now I want to do slightly more with this thing. If the user types a lot, and the user types really quickly, the problem will be that every time this thing fires, we will go to a web service, which costs us a lot of money, lots of network traffic. Maybe, your Windows 8 tablet is on the 3G plan or something. Like, you don't want to suck down the whole dictionary if the user types R and suck down everything that starts with R just because the user just changed his mind into RE a millisecond later. So, like, you want to sort of wait for the user to calm down, sit in the airport lounge, drink a bit of coffee, and at that point you want to make the web service call. Of course, you don't want to wait too long as well. So what you want to do here is you want to throttle this event stream down. You want to say, this will go too fast, but when the user calms down, doesn't type anything anymore, the network request needs to be made. So how do you do that with classic .NET events? You will say, well, that's simple. You just run a timer somewhere, you have a field sitting somewhere, you have some cancellation logic sitting somewhere, and you pull out your hair at the end of the day as well. So we don't want to do that. Instead, what we can do, because it's an observable sequence, I can dot into this whole realm of capabilities here. As you can see, there's quite a bit in Rx. That's the top layer of Rx. So I'm not going to talk about all of those things unless you come to the Belgian country drink tonight. I will be happy to talk about that for hours and hours. I don't drink alcohol, so I sound intelligent even on parties. And so what I will do is I will throttle this thing down for half a second. What does that mean? When an event comes in, there is a timer that makes the event age. So every time you type, there will be a timer started for half a second. If somebody types again within that half a second, the timer is reset and we forget about that event because things are coming in too quickly. But when the user doesn't type for half a second anymore, the event is propagated. So essentially, you're throttling down the stream by making sure that there's at least half a second of pause between keystrokes. And so as soon as that happens, the event is propagated. It's also possible that the user types the same thing twice. Like if you do a backspace, you correct to the same word within the same half a second. Like you would go to the web service twice again. How do you filter out duplicates? Well, as you might guess, there are operators for that as well, called distinct until changed, which basically filters out adjacent duplicates. So if the user types the same thing after consecutively, the second time the event wouldn't be propagated. How do you do that using classic.NET events? You just have a field with the last value sitting somewhere. You make sure that if the field is null, that you do something else, like all of those kind of things. So you don't want to be there. You just do dot throttle. You do dot distinct until changed. So now that I have this, I have an iObservable of string, which is tamed down. It's sanitized. It's beautiful. I could even pass it to somebody else, the guy doing the web service communication layer or something. I could pick it up and pass it to a constructor, for example. Now, instead of doing that, I'm just going to write everything myself over here by including next a reference to a web service I found online, a dictionary web service called dict service. And I will just include that over here by doing an add service. I will call this thing dictionary service, dictionary web service maybe. And if you go to the advanced section in Windows 8, you will see that the only thing you can get here is asynchronous operations. It's all asynchronous. And you will get task-based operations. So that means you will get something that gives you a task of results back, as opposed to begin, end, invoke pair that you had classically up till .NET 3.5 or something, or .NET 4 even. So let's actually include this guy. Now we have a web service proxy sitting somewhere, and I can actually new it up. So let's actually do var service equals new dictionary web service, dictionary SOAP client. And I don't want to see this thing anymore, so let's just import the namespace. So I have a service, and I can do things like match in dict async. You only get the async operations because we're on Win8 here. And as you can see, match in dict async takes in a couple of parameters and returns a task of dictionary word array. That's exactly what I'm after. I want to sort of join the web service now with my text box. How do you do a join and link? How do you query one thing and then the other thing? The answer is you just use multiple from clauses, right? So let's actually try that. Let's try to do something like this. var result equals from a term in the input, from the words in the service.matchInDict, and then pass in the dictionary ID. I will use WordNet. That's just from Voodoo based on the web service that I'm actually using here. I'm going to pass in the term that the user wrote. And the strategy to search in the web service will be prefix strategy. You can find documentation online for this web service. It means everything in the WordNet dictionary that starts with the given term. Like that's basically what I'm doing here. And then finally, I will do select words. What have I done here? I've actually taken an iObservable of string and sort of joined it with something that returns task of dictionary words. What do I get back? The thing I get back is an iObservable of dictionary word array. So whenever the user types, we go to the web service, and when the web service call asynchronously completes, we get a callback that actually gives us the word array that was produced. So now that I have this, the last thing to do is actually bind it to the UI. So I'm going to do res.subscribe, and then when the words come back, I'll actually do list.itemSource equals words. List was the list box, as you recall. So let's actually, first of all, check that the internet connectivity is still working. Seems to be. That's beautiful. And let's actually run this thing now by pressing F5. And I will talk about the details of the code in just a moment. Let's first see this thing in action. as you can see, it's a beautiful UI. And I can type something like React. And what I get back is a beautiful exception. Actually, this was anticipated, so nothing's going wrong here. What's the problem? UI thread, exactly. And you know, that thing hasn't even been solved in Windows 8, like we still have UI thread-like affinity when updating the UI. So how would you solve that? Well, the answer is, of course, you could walk up to the dispatcher and do begin invoke and those kind of things. Well, that's kind of sad to do those sort of jumping around in circles kind of things. In Rx, we have a better way to do it. We have an iObservable of T, which is actually misbehaving. It's misbehaving because, like, the callbacks from the match indict async are happening on the thread pool thread. And what's happening now is that all the rest of the code runs over there as well. It's not really misbehaving, it's just by design that that's what's going on here. Now, because observable sequences are first-class notions, you might get this thing from somewhere totally different, right? Somebody might pass in the iObservable of dictionary word arrays. And so you want to synchronize with the UI. How can you do so? Well, of course, you could write some imperative code here, and as you might have guessed by now, you know, semicolons are my biggest enemy, so I'm not going to do that. Instead, what you do is you say, I have an iObservable of T, and it's being observed on the thread pool. I want to observe it somewhere else. So you can actually take an observable and move it to another place, so that all the callbacks happen in a different location. So what can I do? I can do observe on dispatcher here, which means take the messages that come onto the incoming observer, transition them for the outgoing observer onto the dispatcher. So you basically do a post on your behalf. And so if you have an unknown data source, actually before you bind things to the UI, you typically want to do observe on dispatcher. So let's do F5 again, and now the thing should work. I'll actually go back here and type, well, as you can see, I'm doing backspace and all of those things, and it actually didn't go to the web service at all when I was doing the backspace operation, because this throttling operation is also happening. So, as you can see, this doesn't look completely right, and that's simply because the object model that we get back from this web service is just some wrapper type around the word. It's not just system.string, it contains some additional information. So I can use classic link to object to actually get the words out of those word objects by doing from word in word select word.word. That's the object model of this guy, so like, too bad. You could actually also get a dictionary ID out of it, but like, this is not you know, anything new. This is just linked to objects. It just looks a little funny. And so as we do that, and I go back here, I can type React. I pause for half a second, the web service request is made, and here you see all the words that start with React. As soon as I type IVE after it, you get everything that starts with reactive. So, you know, this, yeah. Those words were added after people used RxV1. So that's the sample I wanted to give you here. So let's actually switch back to the slides and actually talk a little bit about what you saw just now. The first thing you saw is basically doing the gluing code to take an event, whether it's a .NET event or a WinRT event, and turn it into an observable sequence. The second thing we have sitting here, it's called from async pattern. That's no longer needed in RxV2. What you've seen me do actually in the demo is I was simply doing something like from term in the input, from word in something that returns a task. We've actually provided an overload to select many, which is the thing that's sitting behind multiple from keywords in link, like that translates by the compiler into select many call, that accepts a task of T. Now, why is that useful? Because a task of T really is kind of an observable sequence that happens to contain a single element or produce an error. So it's a single value observable. It's kind of an edge case. So we just provide an implicit conversion of task of T to observable on your behalf. You can also do it explicitly if you like, but you no longer have to. In the past, when we only had the asynchronous pattern with the begin and end invoke pair of methods, you had to do this kind of hoop over here where you said observable from async pattern, and you had to give us the delegates to the begin and end operation, and what we gave you back is a function that returns an observable of the return type. And so now, all those things already return a task of T. We can do an implicit conversion of task of T to iObservable of T on your behalf. So that's essentially what this example shows you. Let's talk about some other examples. As I said, this is no longer needed. So we've already seen this demo. Let's talk about one in the slides here and then do a slightly more interesting demo using Kinect. You know, I have a Kinect sensor sitting here, so that's going to be a lot of fun. I need to burn some calories, so I want to jump around. So, but first, let's do, you know, the very, you know, pedestrian, you know, financial world kind of thing as well. So what I have here is an event stream of ticks. In fact, most likely the ticks don't end, so you don't want to see a completion at the end, but it doesn't quite matter here. And so I have a stock stream, and I want to ask the question, please notify me whenever any of the companies I'm interested in raises its stock value, or its stock value goes up by more than 10% overnight. So I want to get an event whenever that happens, so I can do a buy or sell kind of operation. So how do you do that using Rx? Well, you start, of course, by saying from tick in ticks. Next, I want to actually look at the individual companies. How do I look at the individual companies? I group them by their ID. So I can do something like group tick by tick dot symbol. What I get now, if I would do it in enumerable, I get an enumerable of enumerables. When you group an I enumerable of T, you get an I enumerable of I groupings of K, T, with K being the key type and T being the element type. I groupings by themselves are I enumerable sequences. So in link to objects, you already know what a grouping does. It creates like a nested collection, if you will. The same happens with Rx. If you do group by on an I observable of T, you get an I observable of I observables. Whenever a new inner stream is born, because there's a new key value we haven't seen before, you get a new inner stream. You can subscribe to that guy if you're interested in it. So now I get a stream of streams, a stream that actually gives birth to MSFT as soon as MSFT starts trading, and that gives birth to an Intel stream as soon as Intel starts trading. So now I have actually separated or partitioned the stream into multiple streams. Next, I want to compare consecutive values in the streams to make sure that there might be something that goes up more than 10%. How do I actually look at two values in a stream at a given time? I can do something called buffering. What's buffering going to do? It's basically going to slide a window over your stream and basically combine values of the stream. So what I'm going to do here is I'm going to do from open close in company.buffer2,1. What does that mean? Buffer2,1 means create buffers of length 2, which always contain 2 elements, and when the buffer is filled, actually create a new buffer by skipping one ahead. So you will get Monday and Tuesday, Tuesday and Wednesday, Wednesday and Thursday, and so on and so on. So you're basically pairwise combining those values. So now I have an I observable of lists that actually fire for every second value, as you can see. The second time Microsoft sells, you actually get the previous value and the current value. Now I can do a little bit of computation on top of that. I can go into that open-close list, index into position 1, which is the second value, and position 0, which is the first value, and just compute this percentage of change. And then I can do aware difference is larger than 0.1. So you see now I actually project this whole thing, or actually reduce this whole thing, into the places where the percentage goes up by more than 10%. And finally, I can select the company.key and the increase. So now I have an I observable of that anonymous type sitting there, that at the point we notice that the stock value went up more than 10%, we get a notification. So it's as simple as writing those 5 lines of code or 6 lines of code using something you sort of already know by doing link to objects. Now it just applies to event streams as well. This buffer thing is something new that actually allows you to look at windows either based on count or even on time. And we'll actually see buffering based on time in just a moment. Yep.
So what do we end up with?
This output. Okay, so what's the output type of this guy? It will be an I observable of the anonymous type that you have sitting here. The reason is that you actually shaked off the groups over here. Like at this point, after you do the from and the group by, you have an I observable of I observable. Then what you're doing is you're doing a from over the individual groups. So you're actually flattening the groups again by looking into them. So what you actually have sitting here is like at this point you have what we call a higher order stream, an I observable of I observables. At this point, as soon as you do a new from, it gets flattened out again. And so that's what's going on here. Make sense? Yep. So let's take a look at another demo here of doing some complex event processing in the space of, let's actually get the right machine here, sensor inputs. Come on. Okay. Same password, excuse me. Beautiful. So what I have connected to this guy is actually a Kinect sensor. Let's actually see it's still alive. And so this Kinect sensor allows me to do lots of fun things, of course. I'm just going to start the Kinect Explorer, which is a demo application you get with the Kinect SDK. A bottle of water interferes with Kinect, so I'm actually just getting rid of that. And so you see the skeleton stream here, right? You see my skeleton, so I'm doing skeleton tracking. What I want to do is I want to do event processing whenever I get those new skeletons. I want to basically detect when something happens, like somebody's shaking his hand. I want to have something that says the user is shaking his hand. So I can do all of that stuff using Rx, obviously. Otherwise, I wouldn't be here telling you about it. So I don't know how it works if multiple applications are listening to it, so let me just disable it and just create a new console application. Kinect demos need to be console apps. I know nothing else than console apps. So what I'm going to include here is, by doing add references, I'm going to include the Microsoft.Kinect SDK over here. And I'm also going to include our beloved system.reactive, if I can find it. And this thing continues typing. Here we go. System reactive v2o. I'll talk about the 4 assemblies in just a moment. In fact, the 3 assemblies you see here are a direct reflection of the architectural slide you've seen before. Like we've seen interfaces core and this concurrency thing we still have to talk about later on. So I'm just including all of this stuff here. And I'm going to take a little shortcut by using the toolbox just once to actually get the initialization code for Kinect here that I sort of could figure out, but you don't want to see me type all of this stuff. So this is kind of the skeleton plumbing you have to do to basically get the single Kinect sensor. You can have up to, I don't know how many Kinect sensors on your machine. So you actually have to select one. I only have one, so I'll just use single, which is linked to objects. I'll actually write a connection ID just to have some diagnostic information. I'll enable the skeleton stream, start the Kinect sensor, and then just, because everything is asynchronous, make sure my application doesn't quit prematurely. So when I run this, we get this beautiful HID number, which indicates that the Kinect is indeed connected. So now, of course, we want to do something more interesting. Let's take a look at Kinect.skeletonFrameReady, which is a .NET event. How does it look like? Skeleton frame event ready, as you can see over here, is an event handler of skeleton frame ready event args, which is a very original name. If I F12 into that, it seems to be promising in that it contains data, but it doesn't contain data as a property. It actually contains a method called openSkeletonFrame, because this is actually an interop API. They're going to actually do some interop with Win32 here. And so openSkeletonFrame will basically start allocating things, and you get a skeleton frame back, which, as you can see, is an iDisposable. In fact, during your callback, you have to dispose this guy as soon as you're done with it, and you have to do that within 30 milliseconds, because there are 30 frames a second, and 33 milliseconds might push you to the boundary there if there are some scheduling glitches. So you want to be done as soon as possible with this kind of thing. Now, what do you get here? You get some timestamps, you get some frame numbers, you get some things I don't understand, and you also get a skeleton array over here. I just haven't learned all of the intricate details of this tuple of float, 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 float. So what I want to do is I want to get those skeletons out of that thing. What are the skeletons? A skeleton contains bone orientations. It contains joints. It contains the position of the skeleton, whether the skeleton is being tracked, all of those kind of things. Like, you can already see this being an ugly mess of imperative code, right? You have the event handler. You need to make sure to dispose the skeleton frame in time. So you will have a large using statement. If you do something with time, you better copy things out to make sure that you're not accessing something that's disposed already. So like a lot of things will be going on if I would do this using classic.NET events. It's doable, but let's actually try to find a better way. So what I'm going to do is I'm going to use our from event pattern that we've seen before. And I'm going to use some code snippets in case actually it all makes sense. So that's the from event pattern we've seen before. The only difference here is it's the one that actually takes in an add and a remove action. So this one doesn't use reflection to locate the event. Instead, it asks us, how do I hook up to this event and how do I detach from this event? I'll give you an event handler H that you have to take care of. Make sure you subscribe to the event at the appropriate times when you get called. So in fact, I could call this add handler and remove handler as well, just to make it a little more clear. But so this is actually what's going on here. As you can see, in this case, it's from event pattern of t, where this is actually an event args type. So I will get an iObservable of something that contains the statically typed information. So this is pretty simple. I'm just moving this thing into the observable world. Next thing I want to do is I want to take out the skeleton frames. And so the thing I'm going to do with the skeleton frames is I'm going to copy them out as soon as possible. Because I don't want to keep track of when that iDisposable needs to be disposed. It needs to be disposed in the context of the call. As soon as I start putting those things in queues, which happens in Rx in quite some places, you would have a dispose that you can't do anymore because things are overlapped. So I'm just doing something like select to project the skeleton frame onto an array of skeletons. That's what I'm doing here. So what's going on? sf.eventargs will be of type skeleton frame ready eventargs. So I can dot into that one method that we saw when we were doing some object browsing. I can get the skeleton frame. I can allocate an array with the appropriate length. They tell me how long it has to be. Looks a little bit like native code if you ask me. Then I will do a copy skeleton data to that array, and I will return the array, and at that point this thing will be disposed. So now I have an iObservable of skeleton arrays. Well, that's kind of neat, as you can see over here. Now next, Kinect can support multiple skeletons. I'm the only one on stage, so please don't jump on stage, otherwise my demo will start failing. I just want to get one skeleton out of this thing. I could do a multiplayer game as well, of course. But so what I'm going to do here is I'm basically going to get out of the skeleton array the single or default, give me a single value or null, for which actually the tracking state of the skeleton is being tracked. So I'm basically getting the one and only skeleton that's being tracked. You can see not tracked position only, whatever that means, and tracked as well. So you can just get that thing out. And in case tracked is not null, I will return tracked.joins, which actually gives me, as you can see over here, a joint collection, which are all the joints that Kinect is tracking. And if I go into the joint type, I will be able to look where my spine is, where my shoulder is, where my elbow is, all of that kind of stuff. Yes?
Can you re-explain where you use the columns? 2 names?
Oh, the columns for the names? Okay. The columns I used for the from event pattern are basically just C# 4.0 named parameters. So they're sort of documentation for free. In the past, you would actually have written this kind of thing, which is kind of ugly. So they happen to be named like this. That's the reason I can actually write it like that. Okay. So now that I have this, I have the joins. Let's just track my left hand. Okay. I'm just going to track my left hand by actually getting left hand moves. This is where things get interesting. This part is easy. This part is just give me the joints, right? And index into the hand left joint and get its position. So that's my position of my left hand. So now I have an iObservable of left hand coordinates. That's always changing. So in fact, I could already show you this thing by basically commenting this thing out and doing left.subscribe of position goes to, and I'll do over here console.writeLine of pos.x plus comma, you should use string format or something, pos.y, like this. And so there we go. No skeleton is being tracked at this point, but as I go here, it sees my left hand, and my left hand is on the right, my left hand is on the left. Right, left. You see, the coordinate, the x-coordinate is negative or positive relative to my spine. As I exit the window, there's no skeleton being tracked anymore. The stream stops processing data. So that's a pretty easy query so far. Next thing I want to do is I actually want to detect when my hand changes from left to right. How am I going to do that? I'm going to look where the absolute value of the position x is larger than 0.2. It's actually within a window of -1 to +1. So I sort of want to see I'm offset from my spine. If I'm just moving over here, that's not really moving. I want to move enough, from the left and the right. So I'm doing this offsetting kind of thing. And then I'm going to select over here. If the position is negative, I'm going to say my left hand is on the left. Otherwise, I'm going to say my left hand is on the right. Okay? So this is just an iObservable of string that tells me where my hand is. I'm using distinct until change to only get the times where my hand changes from left to right. Otherwise, I get left, left, left 30 times a second. I want to get left, right, left, right. I want to get this kind of thing. So now, at this point, I actually have, if I move this thing over here, rel.subscribe console.writeLine, I should have a stream that tells me when my hand changes from left to right. Left, right, left, right. That's simple. Good. So next, I want to detect that the user is swinging his hand really quickly. How do I do that? I want to count in windows of time the number of times this thing changes. If it changes 5 times in 5 seconds, the user is waving. Right? So, of course, you can tune those kind of things. So how do I do that? Motion detection. I'm going to say, let's buffer the events in windows of 5 seconds and jump 1 second. So the first 5 seconds, second 1 through 6, 2 to 7, and so on. And then for those buffers, I'm going to count the buffers in which there are more than 3 moves. So that's really shaking hands. And then finally, I'm going to do some beautiful UI design involving the console. So swinging the left hand. So let's actually do Ctrl F5. And in fact, I could also do timestamp over here. Well, I will talk about timestamp later on anyway. So I'm here. Nothing's happening. I'm not really changing my hand. But now I start waving over here. And you see my left hand is swinging. It will die out for a while because I have a buffer of 5 seconds that's still skipping ahead. But at this point, like, all the windows that had more than 3 are actually gone. Like, it's moving, so, you know, my 5 moves that I had, or 3 moves I had in the last 5 seconds were still alive in the last 5 seconds. So you see, like, the swinging hand detection here. Pretty simple query to actually do. You can do much more involved stuff. I invite people to actually create a dance central using Kinect. It's not that hard. So with that, we've seen some sensor manipulation using RX as well. Let's actually move to the right machine and talk a little bit more about some of the things we haven't talked about yet. So the layer we haven't talked about yet is the concurrency layer. You might actually have asked yourself, like, how does observe on dispatcher work? How does it change the context where things are happening? How does that buffer with time work? Where does the timer come from all of a sudden? Who created that timer? Well, that's what the concurrency layer does in RX. That's the place where actually work happens. And so it's, as I like to say, it's sort of our VM in some sense. It's also a little bit like the SQL OS compared to like the the relational query engine on top. Like, it's that kind of very similar relationship they have, only far less complicated than the SQL OS. So let's actually talk about concurrency. So what you see here is observable.timer. Observable timer gives you a single shot or a periodic timer. Just by giving it a time span, you can give it a daytime offset. If you want to wish somebody happy birthday, you can do, you know, observable.timer with a daytime offset. You can also pass in a periodic interval. Now, the right question to ask here is, where does this thing happen? And the answer is, whenever we need to do something out of thin air, RX actually has an overload to the operation that accepts something called an iScheduler. And that's the place where work will actually happen. We have meaningful defaults. The default for time-based operations is the thread pool. So we will actually use system.threading.timer in those cases. But so as you can see over here, you can parameterize those guys. So what does a scheduler do as well? It does do synchronization. We've already seen this problem before in WinRT, where you got an exception because you were actually observing something in the wrong spot. Your callback was happening on the thread pool. In this case, what I'm doing is I created an observable sequence using something called return, which creates an observable sequence with a single value in it. It's a single value stream that fires immediately. In this case, like observable return, you may ask, who's calling the on next on my observer? Same question, same answer. There is an overload with an iScheduler that allows you to configure where it happens. So in this case, I did observable return on the thread pool. The default for return is not to use schedulers at all. It's actually to do things synchronously because it's a single value element. So we don't need to spawn a whole new thread pool thread or whatever to do so. But so here I explicitly parameterized it. So the 42 comes out on a thread pool thread. Don't touch the UI over there. That's what this thing is saying. So how do you fix that? You fix it by saying .observeOn, passing in the scheduler where you can touch the UI. So it's also a means of synchronizing in the right place. So what you see here is I passed in a control scheduler for a Windows form control. And in fact, what we've seen in the previous slide is that you can typically abbreviate those things. We have observe on that takes in a Windows forms control, that takes in a dispatcher object. We have observe on dispatcher as well. We have lots of convenience things, but in the end of the day, they call back into the overload that uses a scheduler to synchronize on. It's sort of our notion of synchronization context on steroids, if you will. So what's happening if you do access observe on the form, it means that all the code post the observe on, all the callbacks that happen, are happening on the target scheduler. So this will be posted to the message loop. Label.text equals answer equals X will actually be running on the message loop.
Is this just for this subscription? Another subscription?
Ah, good question, yeah. So the question was, is this just for this subscription? Like, the answer is yes. Like, what you have to do in order to share those kind of things, and that's a whole different topic here, is actually you have to assign access.observe on that object to some intermediate variable. And so every subscription would actually get posted back to that place. So it's not something that changes state in access or something. It's basically hooking a new continuation up that does the right synchronization. So that's what's going on here. So this is the interface. I won't talk too much about the interface. Suffice to say that the iScheduler interface has a notion of time. You can ask what time it is, so it has a clock in it, which is useful for distributed systems. And you also have 3 schedule overloads, one that doesn't take in time, which means do the work as soon as possible. And then you have ones that take in a datetime offset and a time span. In RxV2, we take care of the datetime offset by having a common timer queue. You can learn everything about it on channel 9. We had a video about it last week. Other things you can see here is that there is a tstate parameter, so we can pass some state to the scheduled action, which means we can serialize it across app domains as well. And we have a func that actually runs the work. Think about the func of iScheduler tstate iDisposable as an action with some additional things on top of it that allows us to do things like recursive scheduling, which is a whole subject of its own. So let's not talk too much about that here. Now, what's interesting is how those two things relate. We've seen the observable plane at the top. We've seen the concurrency layer at the bottom. How do those things relate to each other? Is there a lot of mumbo-jumbo between the two? The answer is no. It's actually a very clean and crisp operational layering. So let me actually take you behind the scenes of Rx just for a second. We saw this return thing. Return 42 means if you subscribe to this guy, send 42 to me. Like send 42 to the on-next channel of the given observer, right? That's what return does. Takes in an iScheduler to tell it where to run the on-next from. So how does it work? To create an observable sequence, never implement the interface yourself. Just derive from observable base or use observable.create, which is what we do inside Rx. We say we need to return an observable of t, we'll do observable.create. The thing passed into observable create is the subscribe action. We do some clever wrapping around it to make sure things are wound down, that there are no race conditions. That's the reason you shouldn't implement it yourself. So this action is ultimately what will get called by the subscribe call. If somebody subscribes to the return value of return, this will be called, given the observer that's passed in, modulo some wrapping. So what I have to do is I need to do observer.onNext of value. But I haven't used the scheduler yet. So where am I getting the scheduler from? Well, I'm going to use it like this. I'm going to say return scheduler.schedule. I'm cooking up some state, in this case using an anonymous type, that contains the value that I need to send out, as well as the observer, like who to call back. And then in there, in that action, I will do onNext on completed and ignore the return disposable.empty, which is there for recursive scheduling, which is not used by return. Now, what's the interesting thing here? Do you remember the signature of subscribe? Signature of subscribe takes in an observer returns an iDisposable. The iDisposable is used to cancel the work, to stop the subscription. Where does the iDisposable come from? The thing that stops me sending notifications. It comes out of the scheduler. So when you do subscribe to observable return or observable timer, the iDisposable you get back is something that talks directly to the scheduling infrastructure to stop the work that's involved in that query. So if you do observable return, you get a disposable back that will cancel the outstanding work on the task pool if it's not too late yet. And so that's what we return. It's a very crisp operational layering. It's literally just returning the iDisposable we get back from the scheduling layer. So this shows all the compositional aspects of Rx, the fact that you can return those iDisposables and actually bundle them together. Things like merge and sample are, of course, slightly more complicated. In a sense, you have multiple iDisposables laying around. But so this is essentially the ID. Yep.
Can you cancel the work on a subscription and then do another call? So, for instance, if you was typing in React and then you wait 30 seconds, you backspace and type in micro, would it then stop looking for everything in React?
Oh, yes. So the question was, like, for example, in the dictionary suggest case, if the user types React and nothing's happening for 30 seconds, like we're doing a web service call, nothing comes back, and the user types something new again, like does backspace and types like Microsoft or something, like, what's going to happen at that point? Well, the thing is that the operators we're using there, in this case select many using those multiple from clauses, they wire cancellation through the whole thing. So that means, like, as soon as the new value comes in, we'll actually cancel the previous request. And so we have operators to do all of that kind of stuff. And so typically, all of the cancellation logic is hidden in the query operators. Make sense? Yep. Okay. Good. So that's the operational layering of Rx. Now, what can you use schedulers for as well? Typically, you wouldn't have to care other than knowing observe on dispatcher. That would be me basically serving you salmon, saying, like, just do observe on dispatcher, don't care how it works, like, just hook that up. I want to teach you how to actually catch some fish here by using the scheduler in a different manner. One of the beautiful things of the scheduler is it's a honest interface. What do I mean with that? If you look at that layered cake diagram, the top layers are not floating in the air and sort of bypassing the scheduler layer at all possible opportunities. Everything that needs to be scheduled goes through the scheduler layer. What does that mean? If you swap out the scheduler for something that looks at everything that's happening, it knows the whole state of the universe. Everything has to pass through it, which means you can control, like, how time elapses. You can actually intercept everything that does time computations. Like, please do something Christmas next year. I will say, I will do that in 1 second and pretend it's Christmas. Like, I know it's in the right order. Like, I didn't have anything to do until Christmas. I know the whole truth here. Like, let me actually shrink time down so that I can run things really quickly. And that's historical scheduling, which is useful for example, log processing. Say in your data center you have event logs of multiple terabytes of historical data of how Bing behaved the last month. Like, you don't want to write a query that's sitting there for 30 days because the historical data happens to span 30 days. You want to sort of virtualize time to process that thing as quickly as possible. You know everything that happened. You can sort it, right? Like, you can also use this whole mechanism for testing. And so what we have is a test scheduler that basically lies about its now property. If you ask it how late it is, it will actually return something like time span from ticks 200, which is really small, believe me. So that's what the test scheduler does. What you can do is you can walk up to it and draw a marble diagram in code. You can say, create an event sequence here that produces Bart and Eric at times 300 and 400. Those will correspond to time span from ticks. Like, they're just virtual times. The only thing that matters here is the causality, the order of those things, like what caused what, that kind of thing. Like, you don't really care whether it's spread out in time or not. You just put some virtual time here. So now I have a sequence with 2 elements and a completion message. And now I want to write a query. I want to write a query that actually takes the input and selects the length of the input, the length of the string in this case. IObservable of string goes to IObservable of int. What I want to do is I want to assert that at time 300, 12 comes out. At time 400, 11 comes out. At time 500, the completion happens. Select shouldn't have any impact on the timing. It would be different if I would be doing delay. If I would say delay this whole thing for a week. Like, I would do delay time span from day 7 or something. Like, it wouldn't be 300. It would be 300 plus the number of ticks in a whole week, right? So then you can actually see that time is actually changing as well. So this allows you to test a lot of queries that you're writing in Rx by just substituting the input for one of those mocked sequences. That's the beauty of actually having higher order notions and actually first-class notions in Rx. First-class notions meaning that the only thing that this thing with from and select cares about is it's a function that takes in an IObservable of something. Where you get it from, whether you're getting it from a real sensor, or you're getting it from something that you use for testing, like I want to test my GPS sensor, like that my speed when I'm actually running through the downtown park in Redmond, like, is accurate. I don't want to test that thing every day by running a marathon. I just want to feed it some mocked sequence that says Bart is at that particular long let coordinate at time 300. At time 400, he's there. At time 500, he's there. So you're basically feeding that thing in, and you can simply do it by substituting the iObservable. It's just a function. You don't have to have mocking frameworks and those kind of things. So let's actually give you a little sample of how to do virtual time testing over here. Oh my goodness, I know, it's not locked out this time. That's good. So let's do File New, Test Project this time. Yep. Oh, it's the wrong one. I messed up here. Excuse me for that. Thanks. So let's create a unit test project 2, as you can see it over there. And so in here, just for sake of keeping track of time, I'll just include the test scheduler, which we've seen before, right? The test scheduler lives in an assembly called system or Microsoft.reactive.testing, this guy. That's actually an extension to the unit test framework that we have in Visual Studio. It actually has asserts that know about reactive primitives. So I'm going to include all of Rx. I could also use NuGet include Rx testing. And so here I go. Now I'm going to draw a stream by just sketching some virtual time. At time 210, 42 is produced, 220, 230, 240. So this is a timeline that you could actually draw in pictures as well. So it's producing a stream of ints. What those ints mean, I don't quite care about in this case. Those on-next guys are convenience helpers that we give you if you derive from reactive test. They're basically just wrappers around the type called notification of T, basically just to make the test look very nice and smooth. So that's what we have here. Next, I'm going to write a query. That's my query. So what am I going to do here? I'm basically going to walk up to that sequence, and I need to include system reactive link, because the thing is actually having a squiggly here saying it can't find where. So I need to include system reactive link, which is where our query extension methods live. So the squiggly goes away. And so I'm going to filter the even numbers, select the number plus 1, and then delay the whole stream with 50 ticks. So what this should produce is 42 plus 1, because 42 is even, so it should produce 43 at time 210 plus 50 is 260. 43 shouldn't pass the filter, 44 should pass the filter and should produce 45 at time 280, 230 plus 50, and then the completion message should also still happen at time 240 plus 50. So that's actually what I'm doing. I'm shifting the whole sequence here and doing some like filtering and projection kind of things. I could do things like buffering, aggregation, grouping, windowing, all of the things in here, right? By the way, this is actually how we test Rx itself. So, last thing to do is to assert the thing I actually stated vocally just a second ago. I'm going to assert that those things happen at the right times. So I'm doing res.messages.assert equal, and I think I actually picked the wrong Microsoft reactive testing here. I picked the V1 version, which doesn't have that convenience helper. I need this guy, the 2.0 version. Now I should see, yeah, the squigglies go away. And so I'm asserting that the messages happen at the right times with the right payload. I'm also asserting that the subscription, and we can talk about that separately, didn't live longer than the query had required it to live. Because the query ended at time 240, we'll automatically clean things up for you. So we'll call the disposables so that outstanding timers are cancelled, all of those things. So you can assert that as well. But the real meat of like the functional testing goes into this part where you actually assert the timeline. So now I can just run the tests over here, and what we should see is just something that produces a nice shade of green over here somewhere. It's not running in virtual time, as you can tell. It takes quite a long time. It was kind of a silly joke. And so you see in 90 milliseconds over here, I got that this test actually passed. If I would say, like, I expected 48 at time 260 and I would run this thing, what you would actually get is a red message here that said, expected at time 260, 48, actual I saw 43. So you can actually now start testing your queries in virtual time. So this is actually our testing capability that has actually led or come out of the design of Rx by introducing schedulers. So let's actually wrap up by talking about a few more little things really briefly. And I will actually talk more about those in my Link to Anything talk in half an hour or so. So no worries if you don't catch everything. It will be on video somewhere. But one of the other things we have is an expression tree representation of event stream queries. If you do something like from tick in NASDAQ, where tick.symbol equals MSFT, select tick.quote, you don't want to stream the whole NASDAQ stock exchange to your PC to throw out everything that isn't Microsoft, right? You want to push the predicate to the underlying source. And maybe they have the NASDAQ query language or something that you could send to some API. So you want to be able to translate the user intent to run it close to the data, just like link to SQL picks up a link query and runs it in the database. So we have support for that using something called, over here, IObservable, and I will explain the name in my next talk. It's basically IObservable with a little wire sticking out of it. It's kind of cute, in my opinion. But the beauty of it is you never have to see this thing unless you build a query provider. Like, other than that, the user writes exactly the same code. He's still writing a from, aware, a selected group by, all of that kind of stuff. It just happens that the user intent is captured by an expression tree, and we actually send it elsewhere. And so what this gives us is a picture that looks kind of sunny, as you can tell, where we have 4 capabilities now in the entire data processing space. We do have enumerable with link to objects. That's linked to objects as we've known it since .NET 3.5. We've introduced IObservable, which is linked to events using reactive extensions, now in version 2.0. On top of that, we used to have iQueryable of T to do link to SQL, where you basically pick up an expression tree and translate it to T-SQL, but at the end of the day, you still get an enumerable back that you can for each over. Now you can also pick up a link to events query as an expression tree and run it somewhere else. For example, you could do link to Twitter, asking Twitter to do the filtering on their server. You could do link to WMI events by sending the filters for the WMI events to all the machines in your cloud data center, so that you basically filter for virus attacks or things on the machines themselves, as opposed to aggregate everything to a single poor machine that has to get all of the process start events in the whole data center just to filter things out. You don't want to move data if it's not needed. And so I will actually show link to WMI events in my next talk, so let's actually not bother over here. But you just write like a link query, and it translates into some language called WQL, which is a SQL dialect introduced by WMI. So pretty similar thing. In fact, I will show link to Twitter in my next talk. In fact, Stream Insight, who knows Stream Insight? Okay, it's a product in SQL Server, in the SQL Server family. Stream Insight version 2.1 supports IObservable in that it can actually pick up reactive queries and host them in their server. So you can basically pick up a reactive extensions query, pick it up, run it elsewhere. And that's all done by the magic of expression tree serialization and basically shipping the user intent elsewhere. And so that's one of the things we've actually been working on pretty hard for the last year or so. So finally, this is the final wrap-up. We have lots of cool stuff coming in .NET 4.5, actually for our XV 2.0. We have better together story with async. We've already seen that you could actually just blend in task of T inside your big queries, like we were doing dictionary suggest without even caring that it's a task in some place and an observable somewhere else. So we do some conversions there. We have support for await on observables as well. You can just await an observable sequence. What you will get back is the last value of the sequence. If we give you the last value, you can always write queries to get other values as well. You can do something like element at dot first. You can do something like take 5, skip 2 or something. Like, you can always get other elements as well. You can aggregate your sequence if you want to get all the elements. We don't have blocking operations anymore. We get some platform capabilities, but what I wanted to show you is this asynchronous programming aspect, because that's the last point that people sort of have had confusion about before. Where does observable of T and task of T fit in the bigger picture? Here's the answer. Since day one of .NET, and in fact long before, we've always had synchronous single-value code. It's just called a method call. You call a method, you get something back. You wait for the method to return. That's synchronous completion for single values. Console read line might take a long time. Then we introduced multi-value synchronous processing using link. Using link to objects, for example, you could write a query that no longer has to do for loops and if statements and all sorts of things. Now you write link syntax, and then you do a for each at the end of the day. Okay? That's enumerable, that's multi-value, synchronous, because move next can still block. You could sit there waiting for the database to respond. Could take a long time. In .NET 4, we introduced task of T, and in .NET 4.5 with C#5 VB11, we introduced the await keyword, which makes the asynchronous single value world look exactly the same. You can do if statements, while loops, you can do for each loops using statements, try, catch, finalies, all around await. And we'll split the code apart into callbacks. That's what the language does for you. It's exactly the same code, just other than having await and an async suffix on method names. Where does IObservable fit in? It's the multi-value asynchronous quadrant, where you say, I want to process multiple values in an event stream. Event streams are by nature asynchronous. I want to write a query over that, and then I want to subscribe, as opposed to doing a for each, I want to subscribe to it and get callbacks. So this is the whole picture of what we have starting with .NET 4.5 and C#5. And so, as you can see, you can convert between those two things on the right-hand side easily, and that's what we actually provide inside Rx. We have some implicit conversions in certain places as well. So, async without Rx, why would you actually combine async and Rx? Here's an example. Here I have a web client, I'm downloading some data, and if you want to time it out, you have to write this kind of thing. It's already much easier than it used to be before, when you actually had begin invoke, end invoke, you had to start a timer yourself, like you pull your hair out. It's gotten a little easier, but you still have this little thing sitting there, like task.whenAny, pass in two things, a timeout timer and the operation, and then check something. It's wait for multiple objects EX 25 years after Dave Cutler invented that in Windows NT. So like, it's not gotten much further. It's still imperative style code. So what do we do to make this better? We have a timeout operation in Rx. So if you take your task, convert the task to an observable, you get all those beautiful things. So with Rx, you can actually make async even better and smoother. You can say, I have a web client, I do download string async, convert it to an observable, and do .timeout. We'll take care of the cancellation for you. We'll propagate an exception for you, and you don't lose your await support, because we have await support on IObservable of T. So you take your task, you go to observable, you party on, you do .delay, .sample, .throttle, all of those kind of things, which makes sense for some of the task of T operations. And then at the end of the day, you do an await. And this thing will propagate the exception in this particular case. So, also have WinRT support. We've seen that in passing by just running code on Windows 8. We have support for portable library. All you need to know about that is, like in the future, you can write libraries that are based on Rx that work on Windows 8, .NET 4.5, as well as Windows Phone 8 in the future. So that's what you have there. That's the API surface. You've seen me use platform services. You can go to the MSDN blog for more information. And you have some other stuff there as well. And so let's actually wrap up now. I'm getting kicked out here. I have way too much to talk about. Again, come to the Belgian country drink tonight. I think most of you are not Belgian, so not invited. So I will stand outside the party, and you can ask everything about Rx over there. Or you can come to my second talk, and I will talk a little bit more about those things. We did a lot of performance work. Let's just skip through that. Long message. It's all looking green, so it's much faster. So that's good. The preview of Rx v2, you've sort of seen it because I've used task of T, I've used Metro in various places. Here's the summary, right on time, because the clock actually freezes at 0. It doesn't count negative, so I could actually run and continue talking here in virtual time. It's sort of doing virtual time clock over here, as you can see. So start using Rx to do event processing, whether it's sensors, data center monitoring, working with Kinect, UI processing, all of those kind of things, Twitter. Like you can use the same language to actually describe operations on top of all of those guys. You can download Rx through NuGet or install an SDK. The SDK has an advantage for example, Windows 8 users because NuGet hasn't introduced extension SDK mechanisms yet. So it's actually pretty nice to actually use the SDK for Windows 8 today. We have release candidate of Rx v2 available starting last week, actually, including a large Channel 9 video on that. And we also have forums on MSDN where you can ask questions. We're also monitoring Stack Overflow, so you can also post questions over there if you like. And finally, there are some mandatory slides. You can see me more like in just half an hour from now, or slightly less because I'm going over a little bit. There are some resources, which is something I haven't seen before yet. Very nice animations. There are evaluations apparently, which you can submit online if the internet cooperates. And our company name is Microsoft. Thanks for your attention.